All right, welcome everyone. We are back after a week off because of a release party that happened last week. So instead of IoT Happy Hour, we actually had IoT, I don't know, 7 hours or so of live streaming, give or take. But we're back, and it is IoT Happy Hour number 50. So we are joined by some special guests down that way. Nope, wrong way, that way, that way. We've got Sandeep and Carlo with us today. First, let me give a quick introduction. My name is David, developer advocate at Balena. Over on that side, Mark, you want to say hello?
Hey, hello. I'm developer advocate at Balena as well. And I have a present for you, David.
You do? What could the present be?
It's a 50th episode. We need to celebrate, actually.
Okay.
So I prepared
Let's
something
celebrate
with Alexandra. Let me show you. What do you think?
Oh, I love it. That is awesome looking. 50th episode. All right. Well, that's super cool. And I'm also super excited.
Thank you, Alexandra.
We've got, yes, thank you, Alexandra. Really appreciate it. She is the absolute best. Let's introduce our guests down here below us. Sandeep, you're down below me. Do you want to say hello and give a quick introduction? I don't think you've ever been on the show before.
Yeah. So I'm Sandeep Mistry. I'm based in Ottawa, Canada. Just 6 weeks ago, I started working for Arm as a staff software engineer and been doing some cool projects there. Before that, I worked at 2 local startups and actually Arduino as a software engineer for 4.5 years, and then moved on to some machine learning engineering. And then just joined Arm 6 weeks ago. That's me.
Awesome. That is a very cool background. You know everything. He's a jack of all trades. All right. Carlo, you want to say hello to the audience? I think the audience has seen you around before.
Yeah, it's a bit weird to be on this side of the wall, I suppose. So many of you guys will recognize me from the chat. I watch almost every week. And right now I'm a developer advocate intern at Arm. So I'm still a university student. I'm studying computer science at the University of Sheffield in the UK. Right now I'm in Cambridge. I was meant to go to the Arm Cambridge office, but of course COVID happened, so it's all been remote this year. And yeah, I just make demos, guides, and all kinds of projects for Arm-based devices. Happy to be here.
That's awesome. What a cool role. I mean, that sounds like Mark and I as well. And, you know, we love what we do, so I'm sure you do too. All right. Well, so on the agenda for the day, let's take a quick moment. We are going to discuss how to flash a Raspberry Pi Pico from a Balena-powered Raspberry Pi 4. I have no idea how on earth you have accomplished this, so I'm looking forward to learning about it. We might, Mark's got his Pico ready. I've got my Pico ready as well. Like I've said before, it's incredible how small they are. So before we get into that, though, and actually I think we may have a bonus demo. Sandeep, you might have a little trick up your sleeve with the Pico and something about LoRa. I'm not too sure, but we'll see where that goes. And yes, I shot JR Piception. Before that, I think we should probably play a round of What's on Your Desk. What do you think, Mark? You think these
I think so.
Think these guys have anything on their desks?
And I think Carlo can sing the song because he already has watched a lot of episodes.
Oh yeah, he's a pro. He could actually sing it. But if he doesn't,
I'm not Chris.
I don't know. If he's ready and wants to sing it, he can sing it. If he doesn't, we could go virtual.
I'm tone deaf, so let's go virtual.
All right, we'll go virtual. Mark, you want to cue it up?
Let's do it.
What's on your desk?
There it is, Sandeep. I don't know. You said you had seen a couple of episodes, but sorry if that was a surprise to you there. All right. Let's start off. Mark, do you have anything on your desk, or are you
out of my Pico? It will be super quick. So I have. Let's do some Zoom.
Okay. Yep.
I have these. I don't know if you know what is this.
I do not know what is that. That is an L. It is an L shape and it has a Pi GPIO header on it.
I don't know if anyone in the chat
I don't know
what it is.
Let's see if
Or any
anyone.
guest? Do you know what
Let's
it is?
see if anyone knows. I'll give the audience
Carlo,
a moment.
No.
Something to do with power supply?
Yeah.
Yeah.
Power something. Yeah.
I showed some weeks ago this tank, this box for LoRaWAN gateways. But the problem is that we need because it's metal, we cannot use Wi-Fi anymore. So the plan here is to use a power over Ethernet system.
Oh, nice.
So this is the power over Ethernet that I found, the cheapest one that I found. For Raspberry Pi.
Cheapest one. I hope it works.
Yeah. And this is what I'm testing these days.
All right. Cool. Well, I'll switch over to Blurry Cam just for one moment. It's nothing exciting. Back on the desk this week is one of my old favorites, the Jetson Nano. Doing some experimentation with ROS. So if any ROS experts are out there, please hit me up.
What is ROS?
Yeah, ROS is the Robot Operating System. So I was playing around with some simulated robots, and I needed just a little bit more power. So Jetson Nano came to the rescue. I have a couple of repos that are published. I'll write a proper blog post, and we'll show that off when the time is ready. But other than that, just a Pi and a Pico ready for today's activities. That's it from me. Who wants to go next, Carlo or Sandeep?
Sure. I'll take the lead. So I'm just going to switch my camera.
Okay.
You guys see this?
Yeah.
Yeah. I see
Right.
a
So
plant and some stuff.
definitely need a plant on your desk. It's good for your health, I think. So I've got a pine pie. I've been meaning to play with it. Apparently you can program it in MicroPython as well. So I'm thinking of doing that over the weekend. Got OpenMV board as well.
So this is a watch? Sorry, Carlo, this is a watch?
Yeah,
Yep.
Pine Time is a watch.
It's a watch. Yeah. It's running actually on a Cortex-M device, so it's pretty power efficient. Although that does make it obviously harder to program because you don't have your whole Linux ecosystem to pull from.
Really cool.
Yep.
Yeah. Got some audio processing applications on the Pico as well. So this is for audio output.
Neat.
And then this is just testing out a microphone on the Pico, just to gather audio data as well and do some processing there. This was for a object tracking demo as well. So just lots of microcontroller related things.
Yeah, I see.
That reminds me my Arduino box.
Cool stuff. All right. And iShot JR has most of the same stuff on his desk.
Nice.
All right. Anything else, or we want to head over to Sandeep?
Yeah, that's it for me.
Okay.
Cool.
Let's see. Sandeep, what do you have on that desk of yours there?
Or your
So
wall.
I have a
Or your wall?
DLE sense that I'm testing out again for some ML, tiny ML. Then a feather wing from Adafruit for LoRa communications. A bunch of microphones, so probably you can see me and Carl are working on similar things.
Yeah.
I'll save
a lot of
one
audio.
item for later as a surprise. Then there's the
Surprise. Okay.
RP2040 from Adafruit again,
Mhm.
with microphone touch. And we were joking about this one, but there's a smart toilet magnet that I designed.
Wait. What is that? Hold that up straight. Hold on. Is that a toilet with Wi-Fi on it?
Yeah, connected toilets, just like in CS 2019.
Oh, wow. I don't know if the world needs that really, but all right. IoT toilet. Well, I guess that's the point we've reached. And our first question from iShot JR. Whoa, is that Adafruit out yet? Is that an engineering sample that you've got there, or are those actually shipping?
No, those are actually shipping. I believe there was no stock a few weeks ago, but now it should be back in stock.
No, don't tell him that. He's probably already adding to cart. All right. Well, I think we are probably in good shape to start doing some learning then. Let me take a quick glance at
What's the
comments.
fastest? What's on your desk?
Yeah, we did really good today. Sometimes what's on your desk takes up the bulk of the episode, and then we have like 5 minutes for the...
and any electronics got harmed today, so that's good.
Yeah. All right, perfect.
By the way, before getting into the topic, is still Balena hiring?
Yes, there are some openings. You know what, though, Mark? I didn't check. I might have to have you cover this because...
Can you share your screen?
Yeah, let's do this. Let's do share screen. And let's go have a look. You can see already my device is updating. We'll need that in a moment, but oops, let's get a new tab. Let's go check what is posted. Good call. And are you the future maintainer of Balena Etcher? I'm guessing that most of the folks watching this stream have used Etcher before. That's our flashing utility for USB sticks and SD cards, and we're looking for a maintainer there. Etcher's an open source project, so if you have application building and GitHub and open source skills, let us know. Security engineer, front-end engineer, and design your own role are also there. I think we've talked about security and front-end in the past, and design your own role is exactly what it says. If you've got some crazy idea and skill set that you think you can bring to the table, let us know. All right. Bring that back down. And awesome. I think we are probably ready to kick this off. Who's going first? Carlo, I think you might be going first.
Yeah, sure. So I'll share my screen first.
Okay. I'll bring that in.
Have you seen this? I'm changing the badge.
No, I haven't. How did you even do that? I didn't even know that was possible. Is that a new StreamYard thing or is that an Alexandra thing?
Magic, yeah.
Yeah, wow. All right, Carlo's screen is here. I'm adding it now. And we've got some drawings. Oh, if Chris is watching, he's going to be so happy. He loves this. All right, what are we looking at, Carlo?
Right, so I just wanted to provide a brief conceptual map of what we're building, essentially, just the infrastructure side of it. So you've got GitHub, and everything we're going to be doing today is going to be GitHub only, I'm afraid. Although there is an option for you to do this locally as well, if you want to go that way. So we have our GitHub repository, in which we're going to be hosting our code that we want on the target embedded device. In this case, I'm going to use a Raspberry Pi Pico, but this could actually be any other Cortex-M device, as long as it supports the .elf file format. Then on top of that, we're going to deploy that repository using code spaces, where everything's going to be set up for you already. Within that GitHub code spaces, right, because that's effectively a Linux virtual machine in the cloud, where you have your programming environment as a web IDE, very similar to VS Code, but essentially on the cloud, right? Inside of there, we're going to have our Balena CLI, which is going to let us talk to the Balena OS device, right? And if anything goes wrong at any point, we can always go to our balenaCloud dashboard to debug issues. And the Raspberry Pi Pico is going to be connected to the Balena OS device. So effectively,
looking forward to see that.
Yeah, this is going to be pretty neat.
You can come to this repository.
Okay,
where
get that on screen. Go ahead. Sorry, I didn't mean to interrupt.
Yeah, no worries. It's called microcontroller rig. So we can just have a flick through, and actually you can deploy it super easily just by pushing the deploy with Balena button. So let's do that.
I'm putting that in chat for folks as well.
You can name it whatever you want. In my case, I'm kind of thinking of it as MCU remote, effectively. Although I believe I've used that name already. And you can create it. Cool. So once you have it, you just need to add your device. And obviously production, and you add your Wi-Fi credentials.
Yep.
Now, I'm not going to show that here, but I've already done this part. I figured I could just show it to you already built.
Yeah,
So,
absolutely. That takes a couple of minutes, of course, as well anyways. So
if I switch my stream to my camera, I can show it to you. That's already running. Or I guess I can just to show you this. 1 second.
Wait a second, we will do zoom on your camera.
Yeah, there we go. Okay, we can see. Yep, we've got it on screen now.
So that's already running on this Pi right here.
Okay.
Can you guys see that?
Yep, we can.
Effectively, all we have to do is wire the debug pins. So these 3 pins on your Raspberry Pi Pico, the 3 pins right here, we can wire them to the Raspberry Pi itself. And then using OpenOCD, we can just grab that .elf file and put it straight into the Pico, thus effectively flashing the Pico remotely. So now I'm going to show you how you would actually deploy an actual embedded C file or embedded C project onto the Pico itself. So if I just share my screen again.
Let me get that back. Okay, yep. We'll get that added back in. Coming in now.
Can you guys see my screen?
Yep, got it now.
Cool. So if you could come to this repository, you can effectively use this as a boilerplate template for whatever embedded C project you're making on your Raspberry Pi Pico. So what you would have to do is you fork this repository, or you clone it, you make your own version of it, and then you deploy it with GitHub code spaces. So GitHub code spaces, and I've actually already set up mine. And after you open it with GitHub code spaces, you'll end up with this project. And so what I have here is a test file just to showcase the idea that we can blink an LED remotely from within our online environment on a Raspberry Pi. So in this case, I have the LED pin 1 commented out so that the LED was not blinking on the Pico. If I just uncomment this, for example, let me save that. Then all I have to do here is run the following commands to set up the tunnel from my VM to the Raspberry Pi running Balena OS so that I can get directly into the container. So 1 second. As you can see, the environment, when you open it with GitHub code spaces, will already have all the files that you need.
That environment right there, that is the VM that's running in GitHub itself, or is that actually?
Correct.
Yeah.
This is the VM that's running on GitHub code spaces. Yep. So I'm just adding my Balena CLI to the path.
Sure. These instructions right here, the installation of the Balena CLI is it's very well documented over in our on our site. It's actually also in GitHub as well. It's documented both places, but I can grab that link for anyone. The CLI, of course, is some tooling that allows you to interact with your fleet, interact with applications, preload containers, and more. Okay.
So in this case, I'm just going to log into my Balena CLI.
Link right there.
Okay, typed that wrong. I'll retype that again.
Yep, and you are logged in.
Awesome. So can you guys see the bottom of my screen?
Yeah, that little StreamYard
Yeah, can
thing
you
is.
stop sharing?
All right.
There you go.
Oh, okay,
yeah.
cool.
Yep. It's perfect now. Sure can.
Awesome. So now I just need to see the ID of my device.
Yeah, you're using the CLI. You could also get this information from the dashboard, but
True. Later on, I'll show you a script where
spirit.
basically we automate this with a bash script effectively so that it does it for you. But I just wanted to show this one step manually.
Yep. No, this makes sense. There's 2 devices in the fleet. And you're grabbing the device UUID. Now you're connecting to it through the tunnel.
Cool. So I'll just open up another terminal. And basically, as I said before, I've uncommented this line of code right here.
Yep.
So I should be able to just run my compile script. And at the same time, I've got an upload script that will grab the .elf file and send it over to the Pico, where it will run the OpenOCD command to flash it. And while this is running, it's basically building the embedded C project, and then it's sending it to the Pi. And I'll just share that screen here by switching my camera.
Oops.
Can you guys see it?
I think Mark just killed the. Yeah, we can see the camera now. Yep, and I see.
Yeah, the pin, no? Yeah.
Yeah, and we
Like
see
the LED, sorry.
So we see
So
some
now-
LEDs. Yep.
The LED is flashing. And effectively, if I just want to change the code, I can do that again here from within code spaces. I'll just comment that line again so that the LED turns off, and I'll rerun the last command that I just showed you, the compile and upload script.
Can you do us a favor and add your screen share again? It accidentally went away. We got a good look at the LED, but we killed your screen share. All right, it's coming back in, adding now. And there it is. Okay.
Yeah, so you can code your embedded C project, just run that again, and you have this loop where you can iterate on it remotely. So for example, in our case, one of the issues that we had with some projects that we were developing is that there's some North America versus Europe specific features with the application that Sandeep was developing. And so this way Sandeep could run his code on my Raspberry Pi that is here in the UK and test it out locally on his as well. That way, you can make sure that it works everywhere. You can also integrate this with GitHub Actions so that if someone puts a PR on your repository where you have an embedded Pico project, you could already test that out on the actual hardware itself to make sure that the project still works, right?
Yeah,
so you can imagine all the use cases.
Yeah, that's super cool, that automated triggering as well. We had a question come in. I think it looks like it's been answered, but I'm going to bring it up anyway, just to reiterate. So iShot JR was asking, where is the code space actually executing? Is this all in the cloud? And I think the answer to that, yes.
Yeah.
All right. Which is sort of incredible when you really think about that. That is really, really neat stuff. And sort of gets me thinking about what some of the implications might be. Okay, now you're using a Pico here. You mentioned earlier that you could realistically use any microcontroller that supports, ELF and compiled C. So what are some other devices then? Could we do perhaps like the new Portenta H7 if that has the same debug?
So any ARM device that has ARM SWD, so serial wire debugger, if you have that feature enabled, you should be able to just plug it in and use the same workflow effectively.
And that's pretty neat. So I can start to then see some, industrial applications where you can flash the device. Now, this might get a little bit crazy, can you flash to more than one? You right now have a 1-to-1 ratio of a Pi 4 and the Pi Pico. You've already stated that the Pi Pico could be swapped out for any supporting MCU device, any Arduino, any other that fits the criteria. But could you have multiple? Could you have 2 Picos, 3 Picos, 4 Picos?
Yeah, sure. And I think that's what opens up the possibilities, right? As we said before, if you have some piece of code where, in the case of our application, right, you want to test it actually on multiple devices at the same time because they have a slightly different configuration and you want to make sure that it works everywhere. You can imagine you can deploy this to multiple different testing rigs, right? And that's where Balena really helps us manage that complexity for us and turns it into a really easy problem that you can literally get it up and running within, an hour, right?
Yeah. That's a really powerful solution. I'm going to have to do a little brainstorming on this. I guess the MCUs, the microcontrollers, are going to need to be in relatively close proximity because they are physically tethered to the Pi 4. But I have to wonder, how many meters worth of wire could you really run to the devices as well? Because then you start to get into some situations where, for example, you had on your desk there, and I don't know if it fits the criteria or not, but you have the OpenMV there, that camera, you get into, I know they have one coming that has some thermal imaging as well. Like you said, the Portenta has a camera, I think, as well. You got the various boards that have the microphones on them. So even if you were to get, a good 10, 20, 30 meters worth of wire, you start to open up a possibility where you can do some localized environmental sensing on those MCUs while still maintaining the ability to update them and push new code to them.
Correct. So from a personal home automation perspective, that's what I'm planning on doing, effectively mixing my Cortex-A device, in this case, my Raspberry Pi, mixing that in with some Cortex-M devices that do either the real-time inferencing or the really low power things while the Pi is sleeping most of the time. And then if I ever do want to update the code, for example, as you mentioned, the OpenMV, if I want to update my object detection model or whatever it is I'm running on it, right, I can do that. And without having to rewire anything and be messing around and plugging the OpenMV into my laptop and then plugging it back into my Pi, everything's just done remotely, right?
Exactly. I see. I shot JR. I wonder where you were going with this. Yeah, that's exactly where I'm going with this. How far? I mean, could you run 100 meters worth of wire to the thing? I don't know. You have to do a little bit of testing as to how far away you can make them. But the point is you can start to, or at least within the home, distribute the MCUs, distribute the devices, and then be able to, command and control from one central unit, and literally command and control from the cloud, to be quite honest. That's a really, really interesting use case. Pretty neat stuff. Something we've explored a little bit. We call dependent devices, and you've sort of taken and proven the concept, to be honest.
Yeah. Another thing that I was trying to spin out of this was making a VS Code extension. I might make that, public at some point, but you could also imagine if just for developing on the go effectively, right? Like I'm a guy that on non-COVID times, I like to be on coffee shops or whatever, just somewhere else. And I can imagine a scenario where I can be programming my embedded device remotely as well from within my IDE. So that's another use case that you can have.
Yep, that's a good one as well.
Mm-hmm.
Awesome. Well, is there...
By the way, can you explain the pins that you're using? So these are just for the back?
Mm-hmm. Yeah,
and,
sure.
And you're using the USB just to flash the...
Yeah, that would be good to cover. Yeah, I was going to go check the
Because I think next episode,
see.
David will need to solder the back pins live.
I'm not soldering anything live. I'm not soldering anything. I'm going to find some electrical tape and there was some glue. I'm going to glue them on.
Yeah. If we go here on the Raspberry Pi Pico documentation, flash programming with SWD, and did I skip over it? So this is your wiring diagram effectively.
Okay.
Yeah, so this is if you want to set up the UART interface as well. In my case, I'm not getting any data from the Pico, right? Because I don't have any sensors attached to it, so I didn't bother with this. But you need these 3 pins, and this is your wiring.
Okay. And this is needed, or just?
Yeah, this is needed for the .elf file format. This is how you would put it into the Pico with the debug.
Yeah.
Okay.
In this scenario, you can, I guess probably the more traditional way of flashing the Pico is to hook up over the micro USB and put the device into debug mode with the button, right? Don't you use or flash? I should say flash mode. Use the button and flash it that way. Yeah.
Precisely. So with the Pico in particular, the minor challenge, and the reason I had to do it this way is because you have to press the boot cell button. If you're dragging, for example, the .uf2 file onto the board, right? You need to actually press the button when you plug it in. So,
So if the device is not physically next to you and you can't press the button to put it into that, flash mode, then that's when you use the pins. So AB is asking, can you use the USB port itself to flash? Not in this model. If the Pico is right in your hand and you're looking to flash it, press the button, put in the micro USB, and you can flash. But I guess he's saying, where is the button mapped to? That might be another method to investigate. But otherwise, those that pin alignment that you showed up there.
You have another question?
Yeah, which button? So the button must be mapped to a GPIO, and I have to wonder if it's exactly those ones that you're showing in that diagram.
Yeah, another interesting thing that you can do once you have those pins connected is that you can actually, step through the contents of memory in your embedded device, which as an embedded developer, that's quite useful, right? You want to make sure that you don't have any buffer overflows or anything. So you want to actually be able to step through the code as it's running on the Pico itself. So that's another benefit that you get from wiring the Pico in this way.
Gotcha.
Really cool.
Yeah. Any other questions? I mean, the capability that you showed off is actually really, really powerful. I sort of want to take some time to digest that and think about it. Mark, you and I may have to do some brainstorming on how to leverage this. But
there's a lot of food for thinking. Yeah.
Yeah, there's a lot of food for thinking here. Is right. All right. Well, I don't see, I guess AB was asking where's the button mapped, which GPIO. AB, let's, we can take it maybe offline and have a look through that document, see if it is described in there or in some other documentation, because that could be another way to flash the device. And that might also vary a little bit per device, right? Because if you're using an Arduino or the OpenMV or Oak or whatever, so I guess the GPIO that is mapped to the device is really only Pico specific anyway, but we can go explore that. So with that said, what do you think, Sandeep? Do you have a demo that you want to show off as well? Or Carlo, is there anything else remaining that you want to cover there?
I think now would be a good point to perhaps show the little secret that Sandeep's been working on and tie it back to how it relates to this demo and how the two can kind of fit in together.
All right, let's do it. Sandeep, what's that surprise you've got there?
So I've been working on connecting the Raspberry Pi Pico to the TTN by using LoRaWAN. So
hang on, I'm going to zoom in on you.
Yeah,
here we go.
You can see the Pico with a USB cable connected and a bunch of wires connected to this Hope RF radio module.
Cool.
Yeah, so that was one of my first projects in ARM, is enabling this and making a library for it.
Is that the antenna sticking up? Because
yeah, just a wire antenna.
Mark, do you have your antenna handy? Can you show him what an antenna is supposed to look like? I don't know if you have it nearby or not.
I don't know if
Okay.
Kettle here it's but maybe
Sandeep, you're going to need to step up your antenna game, but we'll let that slide.
for a demo that works, for a POC.
For a demo, that's okay, but for production, that's awesome. So go ahead, Sandeep.
Yeah, well, definitely can't plug that one into a breadboard.
Well, actually, if you have a UFL connector, you can connect it. Yeah.
I saw JR. Is that a clear breadboard?
Yes, correct.
He's probably going to need a link. I think he's probably going to be purchasing that along with that.
There will be shortage of clear breadboards.
Yeah, there's going to be a real shortage. Get your breadboards, your clear ones now, because he's about to go shopping. All right.
I'm just going to share my screen and then...
Okay. I will bring that in. Here it comes. Okay.
So, we were fortunate enough to get Alistair Elan from the Raspberry Pi team to try this out and blog about it. So a big shout out to him because he helped me test in Europe since I'm based in North America. But that also ties in with Carlo's project where we could have one of these hookups in his house and one in my house, and then the CI/CD pipeline could do an end-to-end test in Europe and North America at the same time. And we could extend it to other regions where TTN is supported. We do a full end-to-end test on like every pull request. Another thing we did around this was with the Adafruit Feather format. So it's more compact format. So if you don't want a breadboard, I want something with a LiPo battery charger. There's a write-up by me on Hackster about this. It's pretty detailed. I'll show you how to set up the TTN side as well.
I am dropping those links in the chat.
All in one, or so this is using the Pico processor? No.
Yeah, this is it's an Adafruit board with the same processor as the Pico.
Wow.
The RP2040.
The one you showed off.
So that's right.
Yeah, the Pico has the Raspberry Pi developed and branded MCU on it, the 2040. However, they also they produce the 2040 and I assume sell that to other vendors, and those vendors can then build boards around it as well. So Adafruit, Pimoroni, SparkFun, a couple other vendors have also built boards based on that MCU.
Yeah, correct.
Yeah, I remember the Pimoroni episode, yeah.
Mm-hmm. And Nico is asking if that's TTN v3 compatible.
But wait a second, let's finish the demo and then
Well, we better finish off first,
Yeah, so I decided since TTN v2 is coming to an end this year, might as well write the Hackster article on v3, so you're all set there.
Good job. Yeah, we have still till the 31st, maybe.
Yeah, we still got till
December.
December 31st. No problem. Plenty of time. Plenty of time.
Yeah, so I'll give a quick demo. So I didn't want to attach any external sensors to my Pico, so people could just do this at home with just the Pico and the radio module. So my Pico is using the internal temperature sensor. It's not that accurate, like it's showing 27 degrees Celsius.
That's nothing.
That's something, yeah, especially for you in Phoenix. But here we can see the live data coming in and hex, so like the 1B, it's a bit bigger. No, yeah, see the 1B there is the 27 in hex.
Yep.
And then what I'll do is, as a quick demo for the downlink messages, I can send a message to control the LED. So the board is sending its temperature up every 10 seconds. So I'll schedule this downlink message, and
Okay.
in a few seconds, we should just see a light LED light up. Yeah, there it's on. It's on now.
Yeah, hold on. I'll zoom in on you. Yep, light is on now.
I'll switch it off again. It's not super interesting, but this is a good building block for other people to
It
add sensors.
shows that it's working. That's the hello world of hardware. Is blink the LED.
And what's cool about the Pico is it's dual core, so you could run some machine learning on one core and let the other core handle with the communication stuff. So you might see something on that in the coming months from us.
All right. Well, we'll look forward to that for sure. Super cool. What else? So I got the links into those articles for folks to check out. And then I guess thinking through that, you've got the ability there so you've got the LoRa module. You could even replace that with other, you're using the Pico, but we mentioned some other ones as well. Or actually, no, you're using a Feather, Adafruit there. But you could use the Pico, you could use whatever. And then, thinking through that again, Mark, we've got some pondering to do with, in conjunction with what Carlo showed. You really get into the situation where you can start to manage or control those MCUs out in the field. That scenario now removes the wire, like I said previously, of needing to run, about 100 meters around the house. Now you can maybe even start to push a little bit of data over the air to it. So, all right, we've got some thinking to do over here.
Yeah, absolutely. Because is there any plan to have like a Bluetooth hat for the Pico or anything that you can disclose that it's public? Or
do you want to take that one, Sandeep?
Yeah, I'm not sure about Bluetooth from Raspberry Pi, but the Arduino Nano with the RP2040 chip on it is going to have a Wi-Fi and Bluetooth radio on it. So you can definitely extend to that. I'm sure there's going to be other shields for the Pico that add that capability.
Okay.
That's interesting.
Yeah, now, Mark's, the wheels are turning because now you start to break free even from the wire situation. But okay, I'll have to do some exploration there. Any other questions? Did any others roll in? I don't think so. Anything else to show off? Let me glance over here. I think we covered it all, and I think we've done it in record time.
Absolutely. What's on your desk record time?
Yeah, that's actually what
Demos
saved
record
us.
time.
Yeah, that's really.
We didn't pray to God, demigods.
Yeah. That's what saved us. So I think we're in pretty good shape, unless there's anything else, Carlo or Sandeep, that you want to cover, want to talk about. I think we can probably begin wrapping up.
Actually, AB is suggesting that probably there are some hats for Pico on Aliexpress. What do you think? Are you buying some sensors in AliExpress or?
I have stopped shopping on AliExpress only because I don't have the patience. It takes typically for me here about 5 weeks from purchase to arrival is about the average. Once in a while, I'll get something in 3 to 4 weeks, sometimes 6 to 7 weeks. So I'm going 5 is the average. AB says no. I knew his answer. He gave up also. I will say, however, that Chris, who is in the UK, he's got more patience. He loves shopping on AliExpress. He's always got a package arriving from AliExpress. And he's like, I forgot I ordered that. But he doesn't seem to mind waiting.
You forgotten. Surprise.
Yeah, I forgot. Surprise. There's your 50th episode. Surprise. Forgot I even bought that. So I don't have the patience for it. I know AB doesn't have the patience for it, but Chris loves it. So I don't know about you guys.
For today, I have a funny story about AliExpress. A friend called me and he told me, hey, do you know this hardware distributor called AliExpress? And I was like, what? This guy works on hardware. Like, what? You don't know AliExpress?
Yeah, what are you talking about?
You know the chip shortage. So these guys are the only ones who have 1,000 units of, I don't know what he went to buy. And I don't know what could go wrong. I'm not sure.
I got some ideas about what could go wrong.
I don't know if with this chip shortage, a lot of people is buying on AliExpress.
It takes a year to deliver. I don't know if it's a year. I definitely have forgotten, or the project has already come and gone. So
I actually did order this Ethernet module from AliExpress.
Hang on a minute. Let's get you zoomed in there. Oh, what is that thing?
This is an Ethernet port for
it's Ethernet RMI interface, and I connected it directly to the Pico, and I could do. I built my own Ethernet Mac controller and software. So
I saw that project when you launched that one a few weeks back on Innovation Coffee. Yes, I saw you had attached Ethernet to a Pi Pico. I was curious about that one. Let me find the link. I think you have a write-up on that one as well, too, don't
Carlo
you?
is preparing something.
What is he?
No, I was just going to show that I've also ordered a bunch of stuff from AliExpress to build like a lightsaber that I wanted to make for May the 4th. So I've got the button and I've got the blade itself, and everything else, even though it was meant to arrive like 2 weeks ago, I'm still waiting.
A lightsaber could double as an antenna.
I'm sure I have dozens of things of AliExpress here on my. Feel free in the chat to explain. What's
Sandeep, where is the link to that Ethernet? Was that on Hackster or was that on the Pi? Where was that? I know that I saw it.
There's one right up on it on the Pi blog. Let me see.
Let's see if Google brings that up. How to add Ethernet to Raspberry Pi Pico. I think this might be it right here. Let's drop that into chat. Yep, there it is. Got it. Yeah, that was on their blog. That's where I had seen it. And that was also by Alistair. Okay. Any other questions or any other AliExpress stories rolling in? Comments? I shot Jared will be obsolete by the time it arrives. All right.
Yeah, let's see if we can still make electronics with this chip shortage. I'm kind of worried.
I'm a little curious. We'll see what happens. I know I see stuff like vehicle production lines are being stopped, and thought I had seen Tesla now getting concerned about chip shortage, and so I don't I don't know. And I've been trying to buy a CPU and a GPU even just for a regular PC build for a year, and I can't get. There's never any in stock.
Yeah, we can thank the crypto miners for that.
Yeah, we can thank the miners.
Yeah, absolutely. Yeah, on Helium projects. No, Helium was here some episodes ago, and they are getting crazy amount of hotspots orders that they cannot. They cannot send.
I actually got to catch up on that episode. I haven't seen it, but I'm very curious. Like, why is it that with the Helium network you have to use their own like branded hotspots? Like, why can you not make your own hotspot? Do you know why, Mark?
Yeah, so they opened during summer the alpha program to test the do-it-yourself hotspots. The thing is that
last summer.
Yeah, summer. Sorry.
Right.
Not this coming. Yeah. Last year.
And some people, misused the alpha program and created like fake hotspots. My point is that the Helium software security system was not good enough, so they couldn't control all of these scams. So some people made a lot of tokens without providing real coverage. So this is why they stopped.
So some people ruined it for the rest of us.
That's an interesting mining model, though, because I like the idea of it, that you can just provide coverage, and it's not like you're wasting the energy, because there could be all these actual IoT devices all over the city actually utilizing the network, right? Like it's very different from a lot of these other cryptos where it's like you're just mining for the sake of mining, right?
Mm-hmm. Yeah, it's interesting, this concept of proof of coverage, right? Mm-hmm. So that you prove the coverage with the witnessing of other hotspots, that there needs to be farther than 300 meters from you. And they created like an hexagonal algorithm to check that. And it's really interesting, And it's really interesting to see the community to optimize, their antennas and installations to get this witness and to get this proof of coverage with other folks. It's cool to see crypto freaks getting into the LoRa space. And for me, that's the positive thing. That people is learning about radio frequencies, LoRa, single board computers, and so on. Because at the end, it's a Pi, right? It's a Pi.
Yeah, the Nebra one is a Pi, right? It's a Pi compute.
It's a compute module 3.
Yeah.
We have to talk in one episode about this, David, because it's running on Balena.
Yeah, we will need to have them on the show and discuss how they're going about building it. Obviously, I mean, some of it is going to be proprietary, and some of it will be stuff they want to talk about and show off. Yeah, absolutely.
Yeah, and now Sean is correct. So this week, Helium released like an agreement with a company in the US that is making 5G modems. So the thing is that you can provide 5G like private networks, and then there is the proof of coverage for 5G as well that enables you to mine these Helium tokens. So that's impressive. So what they are going bigger, not just for the LoRa wall, but on other connectivities, and I think that's super smart.
Interesting.
Mm-hmm. Yeah, it's really, really interesting.
Yeah, perhaps they'll give connectivity to everything, like even our IoT toilets. Who knows?
Yeah, we can use that to connect our toilets. All right. Well, on that note, I think we better stop right there.
I will not talk about the piano.
Yeah.
Sorry.
Oh man. All right. Well, any last questions, comments? I think we're probably good. Mark, you want to hit the end button and everybody?
We have more people than before. Maybe we should explain that we are hiring. If you know anyone.
Let's get one last.
You want to share again the screen? So maybe people...
sure can. Let me get that back open.
Sorry for the shameless plug, but I think that's
all right.
That's interesting because if you love Etcher and you would love to be an Etcher maintainer, there is a position open for you.
Coming in right now. There it is. Etcher Maintainer, like we talked about top of the hour, open source image flashing utility that we make. Security engineer, front end engineer, we have spoken about in the past, and design your own role is exactly that. Tell us what skills you bring to the table and why you would be a good fit, and submit it right through there.
And if you design your own role, we will invite you here.
Yeah, because we'll want to know about it. Absolutely.
All right. I think we are good now.
We are. Go ahead. Everybody say goodbye.
See you next week. Not sure. I don't know what we are going to talk yet. Next week?
I don't know either. We have a long list of items.
We know, but let's keep.
Yeah, we better. Okay. All right. Bye, everyone. Thank you.
We keep the cake for the pie for episode 100, right?
Yeah. That'll be for episode 100.
We will be together, and I will be able to
get out of here. All right. Thank you, Sandeep. Thank you, Carlo, for joining.
Yeah.
Awesome
thank you very
work.
much for coming.
Amazing stuff you actually showed off. Really appreciate it.
Thank you.
Have a good weekend.
Yep. Bye, everybody.
Bye.
Bye.